Hello, I'm Marc Vendrell and I'm studying mathematics at UPC and I'm going to be running through my submission of the lab 4. To start, we have solved exercise 1. It asks us to find the coordinates of the origin of the A frame from B. To do that, we know that the x-axis from A and the y-axis from B have a 30 degrees angle between them. From this we can, and this graphic, we can discover that the two x-axes have minus 60 degrees going from the x-axis from A to x-axis to of B. Having this, we can find the rotation matrix. This rotation matrix is this one that lets us transform from B to A. In order to transform from A to B, we'll have to find the transposed rotation matrix. And since that's what the exercise is asking us, this is what I did. Then I use the rigid body relation to find the origin of A seen from B. The result applying the equation is that the origin is at minus 0.54 and minus 4.1. Doing the second part of the exercise, which is to find the coordinates of the origin of B seen from A, we use the information that we already have, and that's the origin of A seen from B. And we use the rotation matrix, the first one we found, to reverse it and find the origin of B seen from A. And that is a result of 3.82 and 1.58. That's the point where the origin of B is seen from A. Lastly, we search the point expressed in A. To do that, we just have to apply the same formula we've been applying this whole exercise, and we are going to multiply that point for the rotation matrix and add the translation, which gives us a result of the point is 6.9 and minus 0.43. On the second exercise, it's asking us to find the affine expression that allows us to convert points from the frame C to the frame B. To do that, we obtain the rotation matrix from the quaternion we've been given by the exercise. We use Rodriguez formula to do that, and this gives us this rotation matrix. Since we already have the origin of point C seen from B, we already have every single unknown value we need to create this affine expression. Then the exercise asks us to find the affine expression that allows us to relate a vector originally from C to the A frame. We first have to find how to transform from the A frame to the B frame using the angles we've been given. Doing that, it gives us the rotation matrix. That's a multiplication between these three matrices, each one using a different angle. The result is the matrix RBA that transforms A to B. Once we have this, that we can transpose the matrix, and we will get the opposed matrix transform from B to A instead from A to B. Once we have that, we can follow some steps to get the affine expression from the frame C to the frame A. This would be transforming from C to B and then from B to A. We know that from C to B, we only have to use the expression we found on the other part of the exercise, and to transform from B to A, we use this formula that we get from the matrix we have found here. Joining these two expressions, we can get this formula. This is the result and is an affine expression to transform from C to A, from any vector from C to A. We finally put the segment in the three frames. C is the green one, is the one we had, and then we transform it into B and then into A. This gives us these three different segments in a 3D space. For exercise 4, we are asked to find the angle between two segments. To do that, we just find the vectors using the 4 points we've been given, and then we find the angle between them. Since we already have the formula to calculate the angle, we just calculate it using the vectors we've found. We find that the angle is 53.1 degrees. Now we find the angle, but for the plane that the camera has. We use it, to do it, we have to find the rotation matrix. Once we find this equation, that's the same we've been using all this time, these exercises, we use the Rodriguez rotation formula to get the 4 points in this alternative frame, the camera one, not the world one. And we get that the angle between the two segments in this frame is 52.55 degrees. Now we show what the vectors are in the world frame, the first one that we were given. And then we make a 3D scene representing the two segments in the second space, the one with the camera.